All right, we're back. We're on page 11 of notes 17 of Calc C. We're talking about polar areas. We've been doing it for a couple of pages. Hopefully you're getting pretty good at it by now. So let's do, now we're gonna move on to like some real polary type things, which means we also are probably moving on to some real calculator type things, because usually it's like set up, then use your calculator to evaluate. So we'll see about that. So when things are bounded by polar, it's like there's not a top curve and a bottom curve or a right curve and a left curve. I tend to think they're bounded on the outside by one curve and on the inside by another curve. So what do I mean by that? Well, in this picture, we have a rose curve. It'd be helpful if, like, I should have redone the notes in color before there's no chance that was gonna happen, but should have redone the notes in color before I started making the videos. So we have this rose curve. All right. Helpful to know how to graph it. Then we have this circle. And so, I don't know, like this region, right, is bounded on the outside by the rose curve and on the inside by the circle, whereas this region is bounded on the outside by the circle and the inside by the rose curve. So some things inside, some things outside. So what we want to try to do here is answer these questions. Find each of these areas, area that is just inside the rose curve. Just inside the rose curve. So what does that mean? Well, this region is only inside the rose curve. This region is inside the rose curve, but it is also inside the circle. And so we don't want that. So what we basically want is this, and then this, and then this, and then this. I think the smartest thing to do is try to find one of them and then just multiply it out, right? So what I think I'm actually going to focus on is I'm going to focus on finding this. And then I will multiply that by 2, which will give me this. Then I will multiply that by 4, which will give me all of them. So I'm finding half of fourth of it. Half of a fourth. That's my goal. Now, how does polar work? Well, for the polar, just think about the rose curve, right? We're going to start here, 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 here. And then once I'm past like this intersection point, I'm not in the region anymore. So what I really want to do is, and I don't know how many colors I should use to like make this useful. If I can figure out this theta, that's where I want to stop the rose curve. I'm going to start at 0 and just kind of like go. So if I just do the rose curve, that'll give me the area of the petal from 0 to whatever. But I also want to take out this, right? So I need to subtract off that. So I want just this. So I'm trying to get, what? Why did it do that? I guess I picked it up. Let me try again. Yeah, it shouldn't do that. There. This is not like super good at coloring. And then I'm gonna have to subtract off this. It's my goal, it's my game plan. So the key thing is I really need to know what this theta is. But this is just gonna be where the rose curve intersects the circle for the first time. So let's see if we can figure that out. So it's gonna be 5 cosine of 2 theta. I don't know what I'm doing there. Equals 3 cosine of 2 theta is equal to 3/5. So theta is going to be 1/2 the inverse cosine of 3/5. Wow. Okay. So here's my plan. I'm going to do rose curve. Let's call this A. Right? So we're gonna integrate A. This is A. Let me highlight that so that we're all aware. A is stored as this value in my mind, and it will be stored on the calculator also as that value. So I want to do just the rose curve. So I'm going to do 1/2 the integral from 0 to A of the rose curve, which is 5 cosine of 2 theta squared d theta. Okay, so that's the rose curve, the full rose curve. I didn't subtract anything off. That's this. Now I need to subtract off the circle from 0 to what we're calling A. So I'm going to do minus 0 to a of the circle, which is just r equals 3 d theta. Okay, so now what is that? That's overall, that calculation gives me this. So I'm on my way, but that's half of what I need. So I need to double that to get this, and then times 4. So I need to multiply by 2 and by 4. So I need to multiply this by 8. So here, I'm gonna multiply by 8. And I'll get an answer on the calculator, but like this is what we're looking for. This is the setup. All right, next part. We want just the circle. All right, so just the circle is gonna be hard to like highlight. I will try to highlight some part that is like just the circle. I'm gonna use a really tiny highlighter. So like this part through here, there, this region is just the circle. So that I hate the overlapping highlighter, pet peeve, but there you go. That's just your circle. I feel like I changed the like diameter or something of that. Hold on, I gotta check. Okay, they're back. Okay, make minor change. That's just the circle. And there's 4 regions that are the same. There's this, 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 this. My advice when you're dealing with polar is find like the first region where it happens and just work based on that. So I want like just that. So I'm gonna say, all right, so I got an idea. And you also may have an idea. I'm gonna do this. So it's not really clear where I'm looking just yet. I'm gonna go, let me add this line. So now this line, in my mind, is splitting that region perfectly in half. So like where should that happen? That should happen at pi over 4. So I believe this will be theta equals pi over 4. I believe that this was theta equals 1/2 the inverse cosine of something, 3/5, I think. Right? Yeah. Okay. So I think it's hard to like zoom in enough, but when you go from the inverse 1/2 the inverse cosine of 3/5, and you keep going until you get to pi over 4, you get this rose curve part. So if I can do the sector of the circle minus the rose curve, that'll give me half of 1, and there's 4 of them. So I should be able to multiply that by 8. That's what I'm gonna try to do. So I'm gonna do the circle from what we call A to pi over 4. And then I'm gonna subtract off the rose curve from A to pi over 4. The real question, it's not like, the question is, at pi over 4, are you getting r equals 0 for your rose curve? Well, 2 times pi over 4 is pi over 2. The cosine of pi over 2 is 0, so yes, you are. So that's what I'm gonna do. I'm gonna do the circle, so it's 1/2 from A, that value we stored as A, to pi over 4. And then it's just the circle, 3 squared d theta. I'm gonna subtract off the rose curve on the same interval, A to pi over 4 of 5 cosine of 2 theta squared d theta. So that's half of one of the regions. So I think that what I'm doing, I'm gonna try to highlight, it's not gonna go great. I'm trying to get this region, right? Because that's what I want. So I guess I picked it up. I don't know. I really don't think I did, but you know, iPad doesn't lie. I get, oh my God, what happened? What is that? Okay, so this region, and then I'm gonna subtract off this region. That's what we're doing. So when I integrate the circle, I actually get the full slice, which is like blue plus, I don't know, peach. And then I'm subtracting off the peach. That's like my goal. So that's 1/2 of it. So I need to multiply that by 2. And then there's 4 of them. So I need to multiply this whole thing by 8. And that's gonna do it. Well, I think. And then the area that's inside both curves. So the area inside both curves, I think I can just do, so like here's a region, right, that's in both curves, would be like this. This is inside both curves. So I think that if I just do the entire rose curve and I subtract off what was in both of them, which was like this, which we already got, that should give me, wait, what am I doing? I want the thing that's in both. If I take the entire rose curve, blah, 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 and then subtract off just the rose curve, I will be left with just in both of them. So I think that's my plan. So to get the entire rose curve, I could go from, there's a lot of options. I can go from 0 to pi over 4, and then double it will give me this, and then times 4. So I could do that. I could do 8 times 0 to pi over 4. Or I could rewind and go from negative pi over 4 to pi over 4, and then just multiply by 4. I'm going to do that. So the entire rose curve is going to be, there's 4 of them, 1/2. We're going to go negative pi over 4 to pi over 4, and then the rose curve. So this is the entire rose curve. And then I want to subtract off the area that's inside both, which is actually the answer to A. So let's call this, let's call it capital A. Let's call it like, I don't know, A sub 1. Capital A sub 1. So I'm going to subtract off A sub 1. That should do it. And then there's a question of, is one order easier than the other? I don't know, probably. Like finding the whole rose curve would have been a good move. I don't know. I mean, yeah, I think opinions may vary on that. Let me just show you how I'd do this on the calculator, I guess. And then we will come back in the next video and do the next one, because this was a long problem. So let's see, doc4, just put a new problem in. Let's say R1 of t is going to be 5 cosine of 2t. R2 of t is going to be 3. So if I just do intersect, what am I doing? Solve R1 of t equals R2 of t for t. And then I'm going to say, like, I want to know when that happens, but only in the first quadrant, 0 t pi over 2. So we get this value. And then I said I was going to store that as k. No, it was a. A is set equal to this. Okay. And then I wanted to do 8 times 1/2 the integral from 0 to a of R1 of t squared dt, and then minus 1/2 the integral from 0 to a of R2 of t squared dt. And like, there you go. That's your answer, 18.491. I don't know how helpful that is. And then what did we do? So I feel like I can like basically steal this and just change it up a little. Do like, we wanted a to pi over 4. I wanted this to be R2. And then a to pi over 4. Yeah, it would be less writing to combine them into one integral. That's always an advantage of doing that. It's 7.495, I don't know. And then I wanted to do 4 times 1/2 the integral from negative pi over 4 to pi over 4. So I do that a lot with rose curves, like back up and then go forward, especially cosine, R1 squared dt. And then I needed to subtract from that my answer to the first one, which was this. So let's see what we get. We get 20 point something. Area inside both. It seems like that should definitely be bigger. So if I add up the area inside both of them, and the area just inside the circle, am I like, is this dumb? This might be dumb. I don't know. Just the circle was, I didn't label them. I don't know. I think this. This should be, what? Is that 9 pi? Yeah, it should be 9 pi. So it makes sense, but I think that like, kind of like, did I use answers to get that? I don't think I did. I think that is a way to check. There's obviously a way to do this where like I just did, like undid what I did, but I think I did two different ways. I think that's a good way to check. Like I got the whole circle by doing the part just inside the circle plus the part that's inside both of them. So, I mean, that's like, in my mind, a little bit of confirmation. All right, let's go back to the notes. I didn't write anything, so like there's nothing new to see, but I firmly, for some reason, believe that I should end these videos while in the notes. So I'm gonna do that. And then I will be back in the next video to mess around with this one. And I think it's gonna be a lot shorter, but who knows? All right, so I will see you there.